Okay, so hi everyone, whoever is watching us live and whoever is watching us on demand. Nice to meet you. I think we'll start by introducing ourselves and then we'll talk about what we're going to discuss today and dive in. So I'll start. My name is Nadav. I'm a business development manager in Granulate. I'm joined here by Omer and Angelica from our team. You guys want to quickly introduce yourselves?
Yeah, so I'm Omer. I'm a solution engineer at Granulate. I'll walk you through most of our product and our idea of how to make profiling into continuous optimization in order to optimize your environment.
Hi, my name is Angelica Hawkins. I'm a business development lead with Granulate, and I'm here to follow up with you on any questions or concerns or requests you might have with Granulate after.
Perfect. Great. So this is basically an interactive session, so feel free to send any questions to me on private or to the general chat in the Zoom meeting. This is also recorded in sake of our people who are doing their day job right now and would want to watch this. So this will also be uploaded. So I'll start by first introducing Granulate, and by that you'll understand how we got to what we're going to present today. Granulate is a real-time continuous optimization solution. What we do is we help companies improve their performance while reducing costs using the different cloud providers, especially, and we have a very special differentiation with AWS. And during this session, we would love to present how cloud users can optimize their infrastructure easily by running different profiling processes, which we'll touch in a minute. So repeating that, my name is Nadav, together with me is Omer, and I'll start by first introducing our roadmap with AWS. Other than the ideas we're going to discuss today, our technology and how you use profiling to get to optimization, we are also very deep into relationship with AWS. So any AWS related questions, feel free to share with us. We know it's a big part of the community. We know it's a big factor that relates to everyone that is a part of the community. Granulate, as it says in the slide, we're an AWS Advanced Technology Partner. We're basically an ISV selling on top of the marketplace of AWS. But in addition to that, we are involved in many different programs and competencies that are part of the AWS ISV roadmap. We're also we have different solutions for different services within AWS, either if it's whether if it's EC2, ECS, EKS, and special differentiations for EMR and Graviton, which will touch some of them in this specific topic today. And of course, you can see on the right some of the partners, the customers that are AWS customers who used Granulate, which is an ISV selling on top of AWS. And of course, if we do have time at the end, we can touch some of the great success stories, but we wanted to focus mostly on the educational part of the technology and the research we've done over the years. And we have very great insights for you guys. So again, feel free to ask us anything related to AWS. I'll pass the torch to Omer, which will present the session for today, and I'm here for any question.
Thanks, Nadav. So again, if you have any questions, feel free to stop me at any point. So as Nadav mentioned, what we want to do in this session is to, from our experience of working with the clients that want to optimize their performance and reduce costs on the cloud, we came to a conclusion that there is a better way or a good way to do that in a full process, integrating with your CI/CD process of development in your code or your dev team. So starting with profiling your code and getting insights into improved performance that might happen on your code and on your cluster, and then real-time optimizing the same way Nadav just mentioned to improve performance using those insights as a whole. So starting from, as the title suggests, starting from profiling your code and moving into optimizing in real time based on the insights from these profiling processes. So we'll start by optimizing. The core premise, or what we saw when working with clients and our companies based on that premise, is that operating system and the cloud, also Linux in particular, were designed as general purpose solutions with the user behind the keyboard in mind. This means they were designed to act on a lot of different services and switch between those on the fly to create a very responsive experience for the user. In order to do that, they are optimizing for a utility function of interactivity and fairness. Production environments, on the other hand, are operating very differently. They are designed to act on specific services that has repetitive patterns in them, and to do this in a repetitive manner in order to perform at scale. So when operating system try to allocate resources for interactivity and fairness in production environments, the resource allocation is never quite aligned with the way the service or app is behaving. So if the client could in some way, or any service provider could in some way tailor the way the operating system allocate its resources for production environments or for the goal of the specific app or service, it would stand to benefit a great deal of improved performance. And we saw that by doing that, we can reduce entire metrics of response time, CPU utilization, reduce costs, all by making zero changes to code or any R&D efforts. So just by tailoring the way operating systems are making their decisions in real time, we can improve performance by quite a large amount. And this is the optimization part. So when looking at this understanding or our insight about how operating systems are allocating their resources, we dove into this process of Granulate of learning and optimizing in real time environments. So just to give you a quick example of how this exactly is possible, or how we can make these decisions in real time better for production environments to improve performance. So this is just a simple request response workload with a microservice architecture. It's supposed to give you an example of this potential from this gap between operating system optimizing for interactivity and fairness and production environments aiming to perform at scale. So you can see here millions of users filing API or SDK requests to a load balancer hitting front-end service A. This service pushes those requests downstream to a few backend services, which in turn interacts with databases and third-party providers to answer the user. So for the sake of the example, you can think of it as a user trying to log into Netflix. So when he tries to log in, he needs to get back his login credentials, his past views, his preferences, or whatever before loading into the page. So the important thing here is that there are dependencies between the answers from the three backend services. So we can't really answer with a partial response. We need the entire batch to answer the user. So we're looking at service A. Service A at any point in time can do one of two things. It can either push a lot of user requests downstream, hundreds of thousands a second, or it can allocate resources to process the answers from the backend services, generally speaking. So we're looking at the point in time in which service X and Y responded to service A, but service Z is yet to respond. This can happen for a variety of reasons. This could be the dynamic of your service or application, or due to increased traffic at the time, or delays in the interaction with third-party providers. Whatever the reason being, this happens all of the time in production environments. And now service A needs to decide how to allocate its resources to handle this specific scenario. So if service A were to allocate resources to process the answers from services X and Y, it will no doubt process these answers. But on a grand scheme of the application, looking at the goal of the application, it will not create any meaningful progress towards answering the user. Because as I mentioned, there are dependencies between the three answers from services X, Y, and Z. So until service Z responded, there are no really gains to be made by processing only those two answers. What we would want service A to do at this point in time is to push more user requests downstream, increasing the throughput and performance of the system for the goal of the app. And then when service Z responded, to process the entire batch together and answer the user. But because, as I mentioned, the operating system underlying service A is optimizing for interactivity and fairness, as soon as the answers from services X and Y create an interrupt on service A, it will allocate resources to process these answers and not push user requests downstream, acting suboptimally. So what Granulate allows you to do, or the way we found we can improve the way operating systems are making decisions, is we will be installed on service A, for example, and by tailoring the way operating system allocating the resources, will become aware of the processing stages and data flow of the service, And we'll decide in this scenario to push more user requests downstream and then process the entire batch of answers together. So this is just an example of how we saw that we can make decisions better at the operating system level in order to improve performance in production environments. It's not that the operating systems are not optimized or are not good solutions. They are very good. They were just designed to do general or multi-purpose functions and not to deal with specifically with production environments, which is what is enabled by Granulate. Great. So now moving on to the profiling. After we saw that we can create this improvement, now the question is how you get there. How do you get to a point where you can optimize your decision-making in your environment? So there are a lot of profiling tools or tools that give you visibility into your code and allow you to profile your environment during the CI/CD process. After you're able to, we thought that this is a good way to start by profiling your code and your environment and getting some insights into functions that are heavily using your CPU with no use or are just running for too long without any necessity. We can make insights that allow you to improve performance and reduce your cost at the end of the month. What we do saw is that current profiling tools that are doing it in a singular point in time and not in a continuous manner are one, needing you to change your code in order to profile your code. And another thing is that it takes a long time for us to get meaningful insights from sampling your code once in a while. So we thought that a better solution to this might be continuously profiling your code, see changes and updates happening in real time, providing insights based on what we know, best practices and known optimization options, and then allow you to optimize based on this profiling process. So you can see here that our profiler, it's an open source tool just for you if you want to use it. It's not a selling pitch, just to give you an example of how we can make this profiling tool suited for this type of process. So it's an open source tool. It's completely plug and play, seamless installation. And immediately after you install it, you will see this type of flame graph showing you on the entire functions in your code, how many of them are being called and how many CPU utilization each of them is consuming at any point in time. So you can make your own decisions about your code. But it will also allow you to, with lower overhead, to do that in a continuous manner. So you'll be able to see your function, how it behaves, and how much it's consuming resources in a continuous time and a wide coverage of languages. So we support Java, Go, Python, Node.js. It's very seamless to install. You immediately see your functions running, and then you can make your own decisions about this process. But looking at the entire picture of optimizations, we thought that a good solution will be to use this profiling tool to give you insights based on best practices and optimization opportunities, and then allow you to act on those insights. So how you act on those insights is the way we see it. After you profile your code and get a good visibility into it, you can install additional optimization solutions to take advantage of the insights you found during profiling. So how we do it is we have an agent-based solution. The agent is comprised of two different modules. It is loaded onto your machines on your cluster or your workload, and then it will start by learning processing stages and data flow based on the profiling information found in the profiling side of the process. And then it will be able, after learning for a few days, to optimize and make decisions in real time at the operating system level in order to improve performance. So the way our agent does it, there are other solutions in the market for cost reduction. But the unique thing about what Granulate does is it hooks onto kernel and runtime level queues in order to allocate resources. It is able to learn them based on a utility function determined with the client. So this can be CPU utilization you want to reduce, latency you want to reduce costs or increase throughput. And then he's able to order those queues at the kernel and runtime level to improve performance, again, based on the profiling insights found in the first phase. So going from profiling to taking advantage of the profiling data to act and optimize in real time. So as I mentioned now, the way we see the process as a whole, or the way we view the world of optimization moving forward, is by first starting by continuously optimizing your code, seeing updates being run in real time every few days, and then get visibility into what functions on a call stack are calling the most CPU utilization or are causing the most damage in terms of costs. And then get meaningful insights by best practices, known issues and known optimization opportunities, and then acting on those insights in order to reduce your costs. So this can be a full-on process happening in real time, integrating with your CI/CD process as a whole in order to reduce your costs and improve performance overall in your dev team's process. So just for you see an example of how clients that we were able to went through this process with. So after profiling their code and then enabling the insights from this profiling method, we were able to reduce, just to understand the graph here, the x-axis is the time it takes the agent to learn a workload after the profiling information is being given to it, and then how much cost reduction it can actually, or improve performance it can actually achieve for each workload. So you can see the Java, Go, Python applications that were profiled and then activated the agent on, we were able to achieve pretty significant amounts of improved performance, so 40 to 60% after a few days of learning, which is pretty significant. We're also having very good results with big data workloads, Spark, Hadoop, EMR, that also allow us by profiling to get into the nitty-gritty of the jobs and how to reduce the job completion time. Also, Node.js is available. So you can see that by going through this entire process of profiling, getting insights and acting on those insights, you're able to dramatically reduce your costs and improve performance overall in your cluster. Cool. So what I'm going to do now is I want to show you a quick demo of me actually implementing an agent or activating an agent on a live workload after we profiled it and got insights into how to improve the performance. So the agent was given this workload after this process already occurred, and then activating the agent will create improved performance in real time based on this real-time continuous profiling of the production environment. So I hope everyone sees the Grafana here. Nadav, let me know if we can see it.
See it perfectly.
Great. So this is a bidding app. As I mentioned, it's a real workload that was given to us from one of our clients for demo purposes. So you can see here, 5 servers giving service to 10 backend services. As I mentioned, it's a bidding app written in Python. And for you to understand the full process, they first profiled their code using a real-time production profiling tool. They got insights into how to improve the workload and how to improve performance and reduce their costs. And then they decided to act on a few of those insights and to install a real-time continuous optimization solution to take advantage of all of these insights in real time. So you can see in terms of metrics, each machine is handling about 119 to 121 requests per second. P90 latency sits at about 53 to 57 milliseconds. The median latency is about 36 to 37 milliseconds. And CPU utilization sits stably at about 62 to 65%. So overall, it's a pretty well optimized environment or service. What I'm going to do now is I'm going to log into one of those servers. I'm going to activate the agent, which will make decisions in real time at the current runtime level in order to take advantage of the insights from the profiling process. So I'm logging into one of those servers. So I'm logged into 168.1.103. You can see it's the green line over here in this example. Just to clarify here, I mentioned that there is a learning phase in which the solution learns the profiling data he saw during the profiling stage. But here, the agent has already learned this profiling data. So immediately after activate, you will start seeing improved performance happening in real time. So I'm going to activate the agent now. Sorry, wrong language. Just for you to see what I'm doing here, we are loading the kernel module I discussed earlier, which makes the decisions based on the profiling data. And we're optimizing in this instance based on latency. We can choose whatever utility function you want to optimize for. So this could be CPU utilization, this could be latency, this could be costs. And then you can see that immediately after I activated, based on the profiling data found by the agent, it immediately starts behaving very differently from the other machines. So you can see that the green line is handling a lot more requests. So about 141 it will stabilize on about 145 requests compared to the 114, 116 of before. Latency, P90 latency dropped to about 43 compared to the 51, 52 milliseconds of before. Median latency dropped pretty significantly, about 35% to 25 milliseconds compared to the 35, 36 of before. And CPU utilization remained pretty much on the same levels and even dropped a bit. So we're handling more requests. You're doing it faster in terms of latency, while maintaining similar levels of CPU utilization and even dropping a bit. So based on this profiling data happening in real time, the agent was able to take advantage of the insights the profiling tool was able to give it, and then improve performance in real time with no downtime and no restart, and improve the performance pretty significantly. By the way, this happens, or the CPU utilization is not dropping significantly because the load balancer just pushes more requests into those machines and increasing the CPU utilization. But if I were to install the agent or activate it in all the machines, CPU utilization will drop significantly on the entire cluster. So just for you to see the full picture, I'm going to also deactivate the agent now. So similar to activation, deactivation, very seamless, as you can see. Immediately after deactivation, with no downtime, we're stopped making decision at the operating system level, and the green line returns to operate the same way as before. So as I mentioned before, starting from profiling your code, getting insights into your CI/CD process of your dev teams, giving meaningful insights into how you can improve your code and improve performance, and giving you another tool to actually act on a lot of those insights and improve performance in real time in a continuous manner in order to get those gains for the long haul. Cool. So I want to show you a few real life use cases of clients that we were able to walk through all of this process and how we were able to reduce their costs in real time. So you can see, for example, here, sorry, I'm going to share the screen. You can see, for example, Apps Flyer, which also went with us to this process. If you don't know, it's an ad tech company, over 1,000 employees in the US. They ran us on a Kafka and Hadoop workload running on AWS based on Clojure. And after going through this process of profiling and then optimizing in real time, we're able to reduce CPU utilization by 25% and reduce costs by 30% by reducing the job completion time on this environment. So you can see here pretty significant reductions after going through the profiling to optimization process. Also, Perion, for example, it's a US-based company, which is publicly traded. Also, proprietary applications running on EMI and AWS, pretty significant CPU utilization reduction, leading to auto-scaling down the entire cluster and reducing costs by over 60%. So also very significantly, and also using this profiling to optimization tool, taking advantage of those insights in real time in order to improve the performance and reduce costs. We also have Fiber, another Germany-based company running a real-time bidding application on AWS based on Java. And also you can see the percentages here after following this full process or the real-time process of profiling and optimization, reaching very good results of 20% increased throughput, 21 reduce latency or response time, and CPU utilization drop are about 60%, which allowed it to reduce its cluster size by over 40% and maintain similar levels of performance. So I'm going to open this session to questions now, unless Nadav, you want to add something, or Angelica. So feel free to ask whatever you want on the solution, on the profiling tool, on the optimization tool, or the process combining the both. We'll be happy to answer.
Thank you, Omer. So we do have one question for now regarding so you've discussed about the process that goes from profiling to actually making the changes, optimizing the infrastructure. Now the question is regarding the agent that is deployed, asking for more clarification for what exactly the agent does to improve the performance of the infrastructure.
Great. So it's a great question, whoever asked that. So what an agent is able to do, it comprises of two different modules. We have a kernel module and a runtime module. The kernel module is able to hook onto resource allocation mechanisms at the kernel level. So CPU scheduler, network, memory accesses, IO, mutexes, whatever executes a queue in order to allocate its resources, and is then able to learn those queues and the patterns of those queues, and to score the different patterns based on a utility function. So this can be latency or CPU utilization. After the learning phase, the agent is able to order those queues in real time in order to achieve or to realize the highest scoring patterns it found during the learning phase. So a real-time prioritization at the queue level to improve performance. And this logic is also applied to the runtime environment. We also have a runtime module. The reason we need the runtime module is that runtime managers mask some of this decision-making from the kernels. So garbage collection, thread management on JVM, for example. And then in order to be exhaustive on the breadth of the thing we optimize for, or to reduce costs on the entire cluster, we want to also apply this logic of reordering the queues in real time to the runtime environment. So the agent is comprised of two different modules, each applying similar logics to the kernel and runtime spaces in order to create improved performance by reordering those queues in real time.
Great. So we'll give it a few more seconds if we hear any more questions. In the meantime, I would like to thank Omer, and to also say that, again, because we were asked due to the time constraints and the time zone differences to record this session, and this session is recorded and will be uploaded. We'll have the community managers share them. And in addition to this, in the slide shared right now, you can find my email. Omer and Angelica are also available if you guys need. Any questions, any references that you guys would like to approach us with, feel free to do so. We can also share some of the content that we shared today, regardless to what is being uploaded. And since we have no more questions, I would like to say thank you very guys for joining us. Thanks, Omer, thanks, Angelica, and thank you, Diane and John, for the opportunity to present.
Thank you very much, Nadav. Take care.
Thank you, everyone.
Bye-bye.